Hey everybody, it's Dr. Schulman, and we're continuing through geometry. We're about to do the seventh bullet point, which is coordinate plane. Now, if you look on yours, if you look at the list of them, 7A just says for coordinate plane, it just says no strategies for plotting points. Now, I'm sure we could do a million, like, that's really simple. It's really straightforward, just plotting points. I'm going to do everything on a coordinate plane just so you can share with your students, so you can teach them more. So I'm going to show you a bunch of stuff with graphs, lots of shapes on graphs, different things you can do with graphs, bunch of different activities. One of the best things I did, I would always have really big graph paper and I'd have a really big ruler so my students can know exactly where to go. Other things you can do, there's like dance transversal where you put the graph lines on the ground and students jump to them. You could do battleships. There's all these different games that you can play. If you want to know more about those, let me know. I have a couple of activities to share, but I just thought I'd throw that out there before we get started. So I'm going to share my screen. You'll see that there's a ton of them, but we're just going to start with the actual, just like some basic information of things that I think would be important to share about the coordinate plane besides just X before Y, plot the point, you know? So this one's going to be a little long, sorry, but I just really want to share a lot with you. So here we go. So here's the coordinate plane. So I'm just going to start with this task. This is something that I built when I was doing my research. I think it's a really good way to first explain to any student about a graph or where it comes from. It's the fifth task right here. After rational functions, here it is. Oh, so it's the sixth task, so I should change that. Number 6. All right, let me edit this. Sorry. Just want to make sure everything's on point. I was working on putting all these together for you. I thought I'd start here because I think this is a good place to start. So if we're looking here, sorry, I just have a lot of things open as usual. Here it is. So I think the best thing you should do is tell them who made this. Who made the X, Y, and Z planes? Well, X and Y for you guys, but who made this? Let me just move this out of the way. Oops. Trying to move this green little spot, but doesn't really want to move. There we go. All right, cool. So this is the guy who made it, Descartes. You should tell them about it. Tell them some stories. Tell your students, I think, therefore I am. What he did, 20 years he served in the Dutch Republic, right? He was in the army. Now, the funny story is, or legend has it, he liked to stay in his bed late, watching a fly on the ceiling from his bed. More of a story is that he never cleaned his place and there were lots of flies. He wanted the best to describe the fly's location, and decided that the corners of the ceiling could be used as a reference point for the X and the Y. Now, I looked more into it. The legend is that it was really smelling. There were flies, and he wanted to figure out where to put the traps the best. But he described this fly's position with the X, the Y, and the Z axis. So it's pretty cool. These are just videos about 3D printing. That's what this lesson's about, where students get to see 3D printed clothes to save money for travel. Like, so you wouldn't have to bring your luggage. You could just print your clothes. They actually came out really cool. Here's a video of it, but look, we can just go to the article. So I think they look pretty cool. The students would read the article. Obviously, your students might not be old enough for this, but I just think it's cool sharing about some clothes. And then, obviously, the point is to show you the cool 3D printed clothes, but it was just about 3 dimensions and things like that. So I'll try it one more time. Otherwise, we'll just look up the designer. Denise Peleg. I think it's just loading. If not, so this is the article where she was talking about her 3D printed clothes. Designer. Yeah, these are her clothes. I think they came out really cool. Talk about like, do you think this would be useful for students? Would you wear some of these? But yeah, these are her cool materials of 3D printed clothes. And then you could do what when you're done? Recycle them. So that was this lesson, you know. There was other things. The other two were like 3D printed bodies. Like the first 3D printed woman was made from cellulose, so they could test cancer treatment. So definitely, if you're going to talk about the coordinate plane, it's called Cartesian coordinate plane. You might as well talk about the guy who made it. What's another fun thing you can do with graphs? Here's one that one of the people that I was training made. It's way better and nicer than mine, but there's two readers, and it's all stories from The Lion King, I think. Oh, it's two Disney stories. I haven't seen these movies, but I know people seem to think Disney is really popular, so she liked it. So basically, it's like traveling around, label the points, going from point to point. You got to label how far you go, and then there's a big graph here. So feel free to use this with your student. They're cute little stories, the Toy Story and distance formula, and the Lion King and distance formula. You got two readers. It's nice. Now, this looks a lot more exciting for students to read and work with than just these, because these are the ones that I've used in the past. Find the midpoint. I'll meet you halfway. Figure out the distance. You write the formulas. You calculate it. Simple. So I've used this one before. Nothing too crazy where you're actually using the points. And the other one that I've used before is this one where they actually make the quadrilaterals, right? You build quadrilaterals from each of these points. You write the length, the midpoint, and the slope, and you get to figure out what they are. So these are kind of fun, right? But obviously, your students probably would like this one better. So think about what you want to share, how to make the graph interesting. I think telling them about who made it and why is something that'll latch onto. Other things that are important to this, here, let me just download this. Just so I have a big old graph to mess with before we look at some other ones. We look at some problems. So here, let me draw things that you should tell your students. This is the X. This is the Y. X before Y, like the alphabet. Remember that little chart I made? X, Y, domain, range, input, output, horizontal, vertical. So they know exactly what to do. It all is like the alphabet. They should know this point in the middle is the origin. It's like the start of their story. They should always read graphs left to right to know what's going on in them. The quadrants go counterclockwise. So that's 1, 2, 3, and 4. You can tell your students you use Roman numerals to not get confused with all the other numbers. And if we have the point, let's say we have the point 1, 2, 3, 1, 2, 3, 4, 5. So this is the point 3, 5. That's the X, that's the Y. You can show them that coming out of this is the Z if you want to be fancy about it. But basically, they should know all these things. These are quick questions you can ask your students. What quadrant am I in? These are called quadrants. You could always just ask them, what quadrant am I in? Things like that, I think, is really helpful for students, just so everybody can answer, right? How many degrees to get to this quadrant? How far is it to the y-axis? You know, there's a bunch of things you can ask, get your students talking. So here is another one that somebody else made. I didn't make this. So you get to pick animals, which is cool, and they're trying them. I did this without the animals. Decide what animal you would like to be and write an extra name. I had questions about this. I was worried that people would get bullied, but if the students chose their own animal, maybe that's better. But basically, they have to cross out whatever ones are wrong. So you cross out one incorrect answer before you find it. I think it's really good for graphing and anything on this. So if you want to graph something, here, I'll download this one too. I didn't make this. I will always give credit where credit is due. I'll tell you all the ones that I made. You could probably tell that they're sloppy. So this one is, this is negative x minus 1. Well, it hits at the minus 1, but the slope is positive. We read it left to right like a book, so this one is wrong. So you can say slope is positive, and here you can see the slope is negative. So you're supposed to just cross out whatever ones don't work. Then at the final and the end, you get we rise up 1, we run over 2. So it's 1/2. So it's this one. Ta-da. And these are really fun because they get to cross out and they get to write why the answers are wrong. They get to work with a partner. So ta-da. I hope that's fun. I always think these are good. These are always really good for students. What else did I put in here? Oh, I just put this one in because I'm not the only one who thinks, you know, Descartes is useful. So this is somebody else. This is from Patterson. And they're just notes. And I have all the Patterson notes, but they're just how you use the distance formula to make a circle. Here, I'll download this so I can write on it for you. This is a formula that students struggle with, but guess what? It actually builds. It really helps them to like understand the distance formula in a different way. Oh, I should have downloaded it as a PDF. Sorry about that. Download as PDF. Not bad. Computer's working hard enough. All right, so when we have a circle, right? What is a circle? It's not a torus. A circle is literally every point. So you can think about it as like your center and then your radius, and it swings around, and every point equidistant from that makes the center. So this is an equation of the circle, x squared plus y squared equals r squared. That's a 0, 0 with 1. So that's this circle. But you can make all these other circles. So you want to know where this one is? I'll just draw one of these. Oh, they give you the answers? Well, that's fine. So if we say 3, 7, and 10, right, this means I have a -3, a -7. Oh, they give us the center 3, 7. All right, so if we get this equation, it's always opposite, opposite. So this would be -5, -1, and then a radius of square root of 11. So it's always opposite, opposite, and then you square it, and that gives you the formula. Going the other way, it's opposite, opposite, square root, and then you can draw any circle from an equation. I just want to show you that. Showing who makes this is always really nice. Okay. So that was enough background information. I hope those are useful. I'm going to go into Delta. I'll probably delete some of them as we go because there's a lot and they only want you to know how to plot a point, which we already did. But I just want you to know more. I hope that's okay that I want to teach you a bunch. Or Math for Teachers. I'm changing the name. Everything's going to go into this one. That's why algebra and geometry are combined. In case other people want to learn the other parts, and we're doing the coordinate plane. So here we go. Coordinate plane, let's make it happen. Oh, that's 8A, that's measurement. We want 7. All right, so here we go. There's a lot of skills here, but we'll figure it out. First one is just plotting a point. You can use technology, you can use the stories, you can draw the tape on the ground, but we just want the point 0. So we don't go left or right, we go up 3. When it's 0, we just stay there, and that's the point. Ta-da! We did it. All right, let's keep going. There's going to be a lot to do. Click on the graph to plot the point. So plot the point 9, 26. So here's 9, here's 25, and here's 26. Click on a point to delete it. That's it? Okay. I'll wherever they want. 9, 26. Beautiful. Let's keep it going. Lots more points. Here's the point 1. Let's do one that's not in the first quadrant. Here we go. This is negative, negative, so it's the third quadrant. So remember how I showed you that, I don't remember where it was. So remember I was like 1, 2, 3, 4. Oh, I'm already drawing, so I can just use this. So another thing you can show your students, origin x, y, 1, 2, 3, 4. Counterclockwise, right? That goes 360 degrees to get all the way back at the start. You can be like 90, 180, 270, 360 back, but everything's positive here. This is negative positive. This is your x and your y for all of them. This one is negative, negative. That's why I knew it was in the third quadrant, and this is positive, negative. So -2, -1, there's your point. We did it. Now let me move my floating head. It's in the way. All right, let's identify a point. So now we're going backwards. So this point is positive, positive, 6, 1. X before Y like the alphabet. Ta-da! All right, let's make it harder. All right, so this is, oh, because it's on the line. So we don't go left or right. So the first point is 0. And it's negative, I believe that is -8. -8. Ta-da! Cool. All right, let's do a horizontal vertical distance. So this is like the distance formula. So we have to plot the points -1, 6, and the point -5, 6. Because it's a straight line, we can just count 1, 2, 3, 4. We can just count that it's 4 spaces. They'll get harder, I promise. All right, let's do it without a plot. So now it says we start at -5, -8. So here's -5, -8. And we're going to -5, -2. Because these are the same, we just have to count from -2 to 8. So it is a -8 minus a -2. Well, it's literally like it's a +2. And I need these absolute value bars because whatever it is, it's going to be positive because distance have to be positive. So it's -6. So it's a positive 6 units. It should be a 6-unit walk from 2 to 8. See if I was right. Ta-da! Cool. All right, so let's keep it going. Here's a points reflected. All right, so now we get to reflect over the x-axis. So we just have to plot it. Here's the x-axis, 1, 1, 2, 3, 4. So it's 1, 2, 3, 4. Remember the formula? We leave when we're flipping over the x. We leave the x, we change the y. So L is -3, 4. And L prime, our new one, is -3, -4. And when we reflect over the x-axis, the y changes sign. Ta-da! I know we did it before, but I just wanted to have every possible one you can try with the graph on here. So we're reflecting over the x. So point L is reflect over the y to L prime. So we reflect over the y. That means the x has to change and the y stays the same. You could draw it if you want, but that's pretty much what you got to do. Ta-da! I like the picture. The x changes, the y stays the same. All right, so now we got to plot a point and say where it is. So it's a what? Negative, positive. So we know it's in quadrant 2. It's a -3, 3, which is in quadrant 2. Nice. All right, let's keep it going. Identify the quadrant. All right, so the quadrant 4, it has to be positive then negative. So which is the only one that's neg? The last one, 6, -6. And you can plot the point. They plotted all of them. They saw it's there. All right, here we go. This will be like one of the ones that you're going to get on your quiz. I'm pretty sure I'll give you one where it's a shape on the graph. So a triangle is drawn inside a rectangle. Okay, that's fine. What is the area of the triangle? Okay, so we know a triangle is 1/2 base times height. Now, this looks weird and this looks weird, but if we have the box around it, we can just use the box. 1, 2, 3, 4, 1, 2, 3. So I'm pretty sure it's just 1/2 times 4 times 3. That cancels to make it 2. I'm pretty sure the area is just going to be 6 units as long as we have a box around each vertex. Let's see if I was right. If not, we'll figure it out. Oh, it's not. Oh. So that's 1/2 of 2 times 3. Wow. Okay. So it's 5 and I want 6. So for this one, we can't just do that. We have to get all the little triangles and then minus the rectangle. Now let's do that again. So here, let's get the rectangle first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So the box is 6 times 4, which is 24. Then I have to minus the thin one. I gotta minus this one, and I have to minus that one. So these are the ones I have to take away. Be left with the shape that I want. What's the shape that I want? It's gonna give me this. So the first one is 1, 2, 3, 4, 5, 6 times 1. So it's 1/2 times 6 times 1. What is half of 6? 3. This is 1, 2, 3, 4. Is that 4? 1, 2, 3, 4 times 1. 1/2. 4 times 1. Well, what's half of 4? 2. That's 2 boxes. And you can see that, look, this goes to here as 1 box. This goes to here as 2 boxes. You could actually have your students color these in to count the boxes. The last one is 1, 2, 3. 1, 2, 3, 4, 5. Okay, so 1/2, 3 times 5. So this is 15. 15 divided by 2 is 7.5. So we're left with 24 minus 3 is 21. 21 minus 2 is 19, and 19 minus 7.5. That's 5. It's 11.5. Ta-da! Beautiful, beautiful, beautiful subtraction. So you're gonna get one like that. I forgot you have to subtract. That's okay. Oh, that was just a level 1? Oh, because it doesn't have the box now. So you have to draw the box yourself. So this is 1, 2, 3, 1, 2, 3, 4, 5, 6. So our box is 18. And we have 1, 2, 3 over 1. So this is 3/2 minus 3/2, which is really just 1.5. Sorry, my pen keeps freaking out. All right, and then we have this one, which is 1, 2, 3, 4, 5, 1, 2. Half of 2 is 1, so this is 5. So it's 18 minus 5. And the last one is 1, 1, 2, 3, 4, 5, 6. Half of 6 is 3. So it's minus 3. So it's 18 minus 8, which is 10. 10 minus 1.5. 10 minus 1.5 is 8.5. That's what it is. So have fun with these. Use your brains. Have them start thinking. Nothing should be too crazy. Yep, that's what we got. All right. So now we get to plot points and identify the polygon. All right, so let's plot these points. I got a -2, 1. I got a 9, 1, 2, 3, 9, 7. I got a 5, 1. Sorry, 5, 1. Just looks like a triangle. It's an obtuse triangle because this is bigger than 90 degrees. That was fun. What? That's what I have. That's what. Oh, I plotted 2 of the points wrong? Well, okay. Let's do another one. All right, so I have a -4, 6. I got a 3, 9. I got a 3, -4. And I got a -4, -1. This is this right though? 3, 9. This is 3, -4. This should be right here. Cool. It is a trapezoid. Where you at? There we go. Ta-da! 4 sides, 1 pair of parallel sides. We got it. We got the shape and we named it. All right. So now we gotta plot and connect the points. When you're done, find the perimeter. Oof. All right, so -9, 3, -2, 3, -2, -6, -9, -6. So there it is. When you're done with the graph figure, it's a rectangle. We can just count 1, 2, 3, 4, 5, 6, 7. So 7 on top, 7 on the bottom. And from 3 to -6 should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 to 9 is 18. So it's 18 plus 14. 32 boxes. Or you can count them all. Oh, sorry. You can count all the way around. The inside's the area. Beautiful. All right, let's do another one. Now it's the same thing, but it's area. All right, so I got a -2, 2, a 4, 2, a 4, 6, a 7, 2, a 7, -7. A lot of points. And a -2, 7. Plot and connect the points in order listed below. All right, let's graph this thing. Throw a triangle at us. That's fine. So we have a rectangle plus a triangle. To get this area, it's going to be this box. We've got to add this box together. But this box is just the area of this one is just length times width. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9 by 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, it's a square. It's a 9 by 9, so it's 81. This is 1, 2, 3, 1, 2, 3, 4. So it's 1/2. 1/2 base times height, 3 times 4. You can just do half of 4 is 2. 81 plus 6, 87. If you count all of these, you should get 87 boxes. I would not recommend counting them all. You will have one like this on the quiz, I'm sure. There's usually one like this where you have to do the area of the shape on there. All right, let's do a dilation. All right, so is dilated factor 1/3 at the origin? So every point has to be 1/3 less. So what's half of 6? 3. What's half of 3? 1. Okay. What's half of 9? 4.5. What? Oh, sorry, it's divided by 3. What's a third of 9 is 3. Oh, okay, so this one's wrong. So 1/3 of 6 is 2. So this is 2, 1. There's your first point. This is going to be, this is 9, so it's going to be 3. Is it 9, 9? Yep, so it's 3, 3. Cool. This one is -9, 9, so this is going to be 3, -3. And here's the last one, which is 9, 6. So this one's going to be -3, 2. This should be the shape. All I did was take every point and divide it by 3 or multiply it by 1/3. Beautiful. Whoa! Magic. All right, so here we go. Let's do another one. Let's get Pythagorean with it. So graph the right triangle with these 2 points. So all we have to do is put the one missing point here. That should connect everything. There's the right triangle. We may now answer the questions below. Leg 1. This is leg 1, 1. So it's from -2 to 7. So leg 1 is 9. Leg 2 is from 9 to 2. So that's 7. The hypotenuse. So 81 plus 49. 9 and 1 is 0, carry the 1. 9 plus 4 is 13, 130. The square root of 130. I'm assuming they don't want me to simplify. Get out of here. I always simplify, but I'm assuming this is what they want for their answer. I called it. I called it. All right. Now we get to do one with rounding. So let's graph it. So here we go. Cool. Leg one from 5 to -4, I believe it's 9 spaces. Leg two from -4 to 8 is 12 spaces. So what is this? We got a round, so it's 9 squared plus 12 squared. So it's 81 plus 144 is c squared. 1 and 4 is 5. 8 and 4 is 12. 225 is c squared. What's the square root of 225? Is that 15? Yeah. Well, I'm not rounding. I'm guessing. I mean, I'm giving them the right answer. Why'd they say round? I don't know. Oh, that's like if it was a decimal. Okay. So now let's do a distance, which is pretty much what we're doing. Find the distance between this point and this point. Okay, so here we go. We're basically just building a triangle here. That's all we're doing. If I have my graph, right, and we have -4. This is -4, 0, and then we have -2, -6, -2. So -2, -6. All we need is this distance and this. We need this one and this one to get the c squared. You can do the distance formula. X minus x1 minus x2 squared plus y1 minus y2 squared. You can do that, right? But if we just subtract it here, we can do a squared plus b squared equals c squared. And that's what we're going to do. So from a -6 to a 0, that's 6. And from a -4 to a -2, that's 2. So it's 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 40 equals c squared, so it's the square root of 40. We could simplify it, but do they want it simplified? Oh, they do. Wild. So we actually I'll show you this. So if we have the square root of 40, we can know that it's made up of a 2 times 20. And this is made up of a 2 times 10. And this is made up of a 2 times 5. When they match, they become a whole number. So it's 4. These two are by themselves. So it's 4 root. Well, what's 2 times 5? 10. It's 4 root 10. Oh, sorry, it just becomes 1. So this comes together as the square root of 4, which is 2. And so it's 2 root 10. I never do it that way. I always do it this way. What's the biggest square root? It's 4 times 10. And then what's the square root of 4? If 4 times 10 is 40, square root of 4 times square root of 10, so it's 2 root 10. That's how you do it. All right, let's do another distance. So find the distance between 2 point round. I guess I should show you the formula. So distance, if you don't want to graph, let's say you hate graphing. Square root of x1 minus x2 squared plus y1 minus y2 squared. So this distance is x1, so -4. -4 minus a -9 squared. So we're like adding these together. So -4 plus 9 is 5. 5 squared is 25. And then the y's is 4 minus a -8. 4 minus -8 is the same thing as 4 plus 8. So that's going to be 12 squared. So it's plus 144. 9, 6, 169. So square root, it's 13. 13. And this is a Pythagorean triple, 5, 12, 13, because it comes out perfect. You'll start to notice them the more you do the problems. These specific numbers that always match. No, I guess I took too long. So we're at the decimal one. Nice. So we did this one, now we get to do midpoint. So distance and midpoint are probably the most common geometry things that you can show a student. The middle and the length. So here's -10, -5. Oh, get out of here. -10, -5. We also have -2, -2, -3. So click and draw a rectangle with the segment as its diagonal. Oh, okay. That's not a rectangle. All right. So this is the midpoint formula in case you want. It's x1. It's finding like the average, and we'll do the average in the next unit where you're going over it. So here we go. But they want us to plot the line segment by clicking. So we have to plot the lines. Oh, because, okay, so -10, -5, -2, -3. Cool. Now I have to click and drag to draw a rectangle with the segment. Okay, there we go. Sorry, I keep getting emails. Just want to make sure it's not important. Okay, just more people submitting stuff. We're good. All right, you must press submit or click the graph to replot. No, there it is. Oh, we just have to, oh, that is so cool. Gives us like a perfect pointer for the middle. So it's going to be -6, -4. That is really cool. To do it graphically, I've never really seen this where you actually get to plot it right in the middle. It's a great little program. What? What did I have? -6, -1, -6. Was my rectangle? Oh, I plotted the points wrong. All right, let's do it again. This is a good problem, though. So it's 10, -1, 10, -1, and 0, 10, -1, and 0, 9. Okay. Now we got to draw this thing. I think I just drew it wrong. Cool. And then we just have to find a perfect match in the middle. Is that perfect? It looks perfect to me. All right, let's see. I've never done one this way. So it's 5, 4. Let's see if 5, 4 is the answer. Nice. Really cool. I like this a lot. So here's one with just the formula. So x1 plus x2, so that's -10 divided by 2 is -5. And then we have a -10 minus 6. And minus 6 over 2, so that's -16 divided by 2. That's -8. Halfway between 0 and -10 is -5. You could also just have your students think about what's halfway. And then this one, what's halfway between -10, -6, -8. Formula works too, but yeah, that's the answer. What do you mean? Because I didn't put the parentheses, we're moving on. Put your parentheses on it because it's a point. Otherwise, they're going to get mad. All right. So I have a midpoint of 4, 1. There's M, it's 4, 1. And we have A, which is 5, 4. A, which is 5, 4. And so what does B have to be? B has to be over here, right? So if this is 5 to 4, this one has to be 3. The first one's 3. This is what I did. I was like, I've got 5 on one side, 4's in the middle, so it's 3. Or you could use the formula if you want. All right, so that's the first one, and I'm not gonna forget my parentheses. And now I have 4 with 1. So if this takes, ready, 1, 2, 3 spaces, this has to go to 0, -1, -2. So it should be 3, -2 is the answer without using the formula and just counting. Ta-da! Here's the formula way. I thought we could just count and look at it, but that's me. There's the graphical way with the counting that I did. There's the algebraic. There's graphical. Cool. All right. Let's do a ratio. So the coordinates of the point on the directed segment that partitions the segment from 5 to 4. What? So we have 1 point at -6, 10. And we have 1 point at 3, 1. And we have to say that this is 5 of them and this is 4 of them. So this is 5x and 4x. So 5 to here and 4 to here. So there's got to be an interesting way to do this. -6 to 10 is 9, so this is 4.5. The middle is 4.5. And 10 to 1 is 9. So the middle is negative, sorry. This is we add them together. So the first one, -6 and 3 is -3. So it's a negative 1.5. And this one is a positive 4.5. So that's if it was 1 to 1, right? If it was the middle. But we don't want the middle. But we have this. We know 5x and 4. So 5 to 4 will give us, let's see the solution. Okay, so the total is 9. So we have to multiply this by what? 5/9. Then we have to multiply this by 5/9. Okay, so why is it 5/9? Is this one 5/9 also? The new x is 5 out of 9. The new y is 5 out of 9. Oops. Let's just do a new problem. Oh, wait, I want the question. Cool. So here we go. -5 to 2, -5 to 9. And we're doing this 1 to 6. So the difference is 1 plus 6. So it's 1 over 1 plus 6. So ours is 1/7 of the way. So we're going to figure out whatever this one is, we multiply it by 1/7. We'll figure out whatever this is, we multiply it by 1/7. Pretty sure that's how we do it. Nice. All right. Well, I'm going to not make you do these because they're tough. So I'm taking this one out, which is totally fine. So let's do a perimeter around the points, something that's nice and easy. Oh. All right. So 0, 7. That one was too hard for you guys. 0, -1, and 8, 7. Here's our triangle. What? Oh, I put it on 7, 7 instead of 8, 7. Sorry. So the perimeter from 0, 7 to 8, 7 is 8. So one of them is 8. The first one is 8. 0, 7 to 8, 7. 8 is up here. I'm having a moment. All right, from 7 to -1 is also 8. And so this is 8 radical 2. Now, how do I do that in my head? Well, these are both 45s. This is an isosceles right triangle. So isosceles right triangle is always a radical 2. I'll show you. So if I did a squared plus b squared equals c squared, I've got 8 squared plus 8 squared equals c squared, because we don't really know this yet. 64 plus 64 is c squared. That's 128 equals c squared. You take the square root, you take the square root. This is really just square root of 64 times 2, 8 radical 2. So it works every time. It's always number, 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 radical 2. Radical 2 times 8 plus 16 for the other two sides, 27.3. And I said I'd delete some. I should delete some more. What if the ones get too hard for you? Ta-da! Got it. All right. Coordinates that make a rectangle parallelogram. Okay, this one's not bad. -1, -3, -3, -10. We got a -5, -5. Okay. And we want D. We have to plot D. We'll form a parallelogram. So we go, ready? 1, 2. It has to be the same slope. 1, 2, 3, 4. So we're going to go down 1, 2, 1, 2, 3, 4. There's your parallelogram. So it's going to be -7, -12. It just has to be the same slope because these are two parallel lines. They're never going to touch. Nice. Where's the other one? Did they not even put it on there? Ah, there we go. -7, -2. Nice. Beautiful. They did it like 5 different ways, but either way we got it. Oh, because we could have put it there too. We could have changed what it was. All right, let's do a triangle. So we got 3, -5. Oops. 3, -5. 8, -5. Where's the top? 0, 2. Let's graph this thing. 3, -5 is wrong? Oh, because I did -3. It's my bad. 3, -5. I'm glad they tell us that. This is an acute scaling. None of them are the same. Oh, that's a lot. Scaling and not right. So FG is, so for slopes, that's positive slope. That's a negative slope. This is 0 slope, horizontal, and this is undefined. When it's vertical, it's undefined. Now we want FG, it's horizontal, so that's 0. GH is, we're gonna go, I need a perfect cross. Is that really the first perfect cross? Crazy. So -5/8. What a crazy one, -5/8. All right, let's do the slope of HF. That's not perfect either. This is -5/3. Notice that both of these are negative. They're both going down. We need the length of FG. That's 1, 2, 3, 4, 5. We need the length of GH. So we can think of this as a point, and this is a point. So this is going to be 7, and that's going to be 8. So to get this distance, I need this to be 7 and this to be 8. So that's 7 squared plus 8 squared equals c squared. 49 plus 64 equals c squared. 9 and a 4 is 13. Carry the 1s. That's 113 equals c squared. So it's the square root of 113. Now we need the length of HF. So this is also 7, 3. So this one's 7 and 3. I'm just making mini right triangles to get it. 7 squared plus 3 squared equals c squared. 49 plus 9 equals c squared. 9 and 9 is 18. We have 58. Can I divide this by 4? Nope. Okay. I'll just do square root of 58. Scaling and not right. The following slopes are incorrect for GH and HF. Gotta be kidding me. All right, so we go down 1. Let's do HF. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So it's -7/3. That's not what I have. So down 7/3. I don't know what I did wrong. In HD, we go down 7/8. So this is -7/8. I don't know how I got 5. Thanks for letting me know. I made that little mistake. Slopes, distance, solutions. No, we're not going to do a level 2 of this. All right. So we'll do the same thing. We'll do the level 1, but we're not going to do the level 2 without the graph. So we got 3, -5, 3, 1, 7, 8, and 1, 1, 2. Okay, this is the weirdest looking quadrilateral I've ever seen. 7, 8 is wrong. 7, yeah, it should be over here. Sorry about that. All right, let's do these. So, it looks like a rhombus. Do we have a rhombus choice? Oh, that would have all these be equal. So it's either a parallelogram or a rhombus. So let's get the slopes. IJ is positive. We rise up 1, 2, 3, 4, 5, 6. We run over 1, 2, 3, 4, 5, 6. Oh, it's just 1 to 1. So it's 1. JK is, this one's not perfect. So this one we have to rise up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So this is 7/4. Slope of KL is also 1 to 1. Great job. And LI should also be 7/4. So we go up 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Sweet. This shows that they're parallelograms because the opposite slopes are equal. Now we just need the lengths. These should all be the same size. So let's just do IJ. So 1, 2, 3, 4, 5, 6. 1. So this is 6. I thought it was 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh, so it's 6, 6. So it's 6 radical 2. Um, 1, 2, 3, 4, 5, 6. What is this? From 2 to -5, that's 7. And this is from, this is 7. That's 7. And this is 1, 2, 3, 4. Oh, because this one's 7/4. So these are different. So these two are going to be 6 radical 2. So it's not a rhombus, it's a parallelogram. 6 radical 2. And both of these are going to be 4 and 7. So 7 squared plus 4 squared equals c squared. So that's 49 plus 16. 9 and 6 is 5. 65. Square root of 65. It ain't no rhombus. They're not quite the same, so it's a parallelogram. What? What's wrong? The following lengths are incorrect. KL and LI. Oh, I have them backwards. My bad. 6 radical 2. Square root of 65. My bad. We all make mistakes, right? I just wrote it backwards. Cool. 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 All right, let's get rid of the harder version of this. All right, let's do an area from coordinates. Something nice and easy. So 3, 8, -5, 4, -3, 0, and 5, 4. So we have a -5, 4 and a 5, 4. Okay, graph this thing. 5, 4 is off. Oh, yeah, it's over here. Nice, it's a rectangle. So all we need is the distances. So we just need one side. This is 1, 2, 3, 4, 1, 2. That's 2 squared plus 4 squared equals c squared. So that's 4 plus 16. This is the square root of 20. Okay, so we need the square root of 20 times the other side. This is 3. That's 5, so that's 8. This is 8/4. So 64 plus 16. 6 and 4 is 0, carry the 1. Sweet. So it's the square root of 20 times the square root of 80. All right, well, what's 20 times 80? And we take the square root of that, we get it. Or we could have just counted the boxes. The answer is 40. Or we could have counted the boxes. Beautiful. 4 root 5, 2 root 5. Oh, that's nice. They waited to the end to they simplified in the beginning instead of waiting for the end. This is 4 square root of 4 times square root of 5. So this is 2 root 5. This is, what is that, 16, right? Yeah, this is square root of 16 times square root of 5. So this is 4 root 5. 2 times 4 is 8. 5 times 5 is 25. It's 8 times 4, which is 40. Yeah, their way was better. Not going to lie. See if we're going to do this proof. All right, this seems easy. Negative 8, 8. Negative 4, 9. Negative 2, 1. Let's make the triangle. All right, I will prove the triangle is right. Really? So PON has to be the right angle. It's 3 sides have no. It's 3 sides no. It has 2 sides that are equal in measure. It's this one. 2 of its sides are perpendicular to one another. This one seems too challenging, but that's fine. So we have to say that 2 of the sides are perpendicular. We have to say that this one is perpendicular to this. So parallel, the slopes are equal. And this one, the slopes are perpendicular, so they're negative flips. And that's what we want to prove. We want to prove that NO is perpendicular to OP. NO, the rise is 1. The run is 1, 2, 3, 4. So that's 1/4. So the other one has to be a -4 slope. OP, we go down 1, 2, 3, 4 over 1. Perfect. 1, 2, 3, 4 over 1. Yep. -4. They are negative reciprocals. They are perpendicular. Therefore, it is a right triangle. What a hard one. Real challenge. All right. Let's do one with the quads. -5, -9, 2, -3, 4, 6, and finally -3, 0. 4, 6 is off? Yes, it is. I'm always off on one of them. We have to prove that it's a rhombus by all sides being equal. One pair of opposite sides, both pairs of all sides are equal. All sides are equal and adjacent angles are perpendicular. No, that's a square. And this is parallelogram. That's what we need. So we have to just say that all the sides are equal. I'm just gonna go on a limb and just say it is. So this is, let's do the easy one. So this is -3 to 4, so that's 7. And this is 1, 2, 3, 7, and 6. This is why the Pythagorean theorem is so important. You can use it for everything. This is 49 plus 36. 9 and 6 is 15, carry the 1. So we've got square root of 85. So we know it's 5 times 17. That doesn't help us. I'm just going to make them all the square root of 85. I'm pretty sure they're all going to match. They look like they match. All sides are equal measures, therefore it is a rhombus. Ta-da! If these were perpendicular, they'd be right angles, but these are obviously not right angles, so that's why it's not a square. All right. We did this before, so we don't have to redo the rotational symmetry. And we don't have to redo the lines of symmetry. And okay, cool. So how does this look the same? Reflection over the Y, nope. It's not gonna match. Reflection over the X, that's not gonna match. So a rotation of 180. If I spin 180 degrees, that'll match. Nice. Spin that thing. 90, 180, match. Cool. The rest of them aren't gonna match, see? Nope. This one isn't gonna match. Nope. And 90 doesn't go far enough. Cool. Equilateral triangle onto itself. So a triangle has three sides. So 60. So every 60 degrees it matches. So it's 120. Cool. Thought it would spin. I guess not. So if we translate 2 units, left 2 and up 5. Left 2 is -6. Up 5 is -1. Nice. This is just going backwards. So if it said we went 3 to the right, we have to go 3 to the left, which is -8. It's saying it's going 4 up, so we have to go 4 down, which is 9. Going backwards is always a little tricky. Reflection of a point. If we reflect it over the line y equals x, so if we're reflecting anything over this line y equals x, doesn't matter what it is. So we have 0, -1. It's just going to be the opposite term. So it's going to be -1, 0. You just flip them. The y becomes the x becomes the y. All right, let's reflect over a point. This one's fun. So I have the point -8, 7. Reflecting over the point -1, 1. So our origin is here now. So if I go from -8 to -1, how many spaces is that? That is 7 spaces. So 7 more spaces would be 6. And then we have 7 down. This is 6. And 1 minus 6 is going to be -5. So feel free to take your time with these. They're a little tricky. Obviously, their picture's way better than mine. Use the graph paper. All right, let's do a couple more. What is the image of 3, -7 moved 270 degrees counterclockwise? I have the point 3. Here's 3, -7. 90 degrees would be here. 180 would be here. 270 is here. So we know both of them have to be negative. I believe they're just going to be switched. I believe if we're here, it's going to be -3. Sorry, -7, -3. In my brain, that's how it's going to spin. I don't really want to look at the rules. Nice. Here we go, dilation of a point. We're just multiplying it by 4 to both of them, so it's going to be a -8, 4. Where are the graphs? They're not showing me any graphs. All right, we already did this, so this mixed one's leaving us. Rotation and reflection rules. Ooh! Reflection over the y-axis. That means the x changes and the y stays the same. So -8, -2. Nice. Rotation 90 degrees. Oh, I don't remember all my rules. I would need to see it. I believe it's going to be -6, -8. Yeah. This one, I'll make it do 4. If you get 4 right, that's good. All right, so we've got a composition. So we're doing 2 things. So it's 7, 5. So first thing we have to move it. So I have the 0.75. I gotta go. So this is first. So this means 5 to the right. So we were here. 7, 5 becomes 12, then up 3. So it's 12 eighths. And we cut it in half. So half of 12 is 6, and half of 8 is 4. 6/4 is the point. This always happens first. The figure below is rotate 180 degrees clockwise. Okay, so it's here. What are the coordinates of point R? So if we're here, I believe I just have to make them both negative. So negative 7, 5. We're gonna go 7, negative 5. And we're not gonna do level 2s of these. I will take out the level 2 of that. So whatever level 2 was this one. Yeah, we'll take that one out. All right, so let's do a congruence versus rigid motions. We did we did this one already. All right, so let's do this one. Coordinate that makes it parallel. Negative 5, 5, negative 7, 9, H negative 1, 9, and I are X 5. Find it such they're parallel. So the slopes have to match. So we know this slope has to match this slope. So we are rising 6 because negative 7 plus 6 is negative 1, and we are running nothing. So it stays the same. Yeah. So we just have to rise this one 6. What's negative 5 plus 6? It is 1. There's the slope. There's the other slope. So much better with the graph every time. Graph some parallel lines, nothing too crazy. Click and drag. We just need a parallel line. Ooh, nice. That's a 0 slope, and this one's also a 0 slope. Beautiful. Let's do another one. Oh, it's the same. All right, here we go. I want it right next to it. This looks a little off. That looks really halfway. No matter how I put it, it doesn't want to be perfect. There we go. Cool. Original slope is down 1, 2, over 1, 2, 3, 4. Is it really 2, 1? Yeah, it is. So it's down 1 over 2. So it's negative 1/2. Negative 1/2. Undefined would be straight up and down. We want a perpendicular line. Click and drag to plot a perpendicular line. The line will change colors. Okay, cool. So the slope is undefined, and the new slope is 0. Let's do one more. This is a slope of, we rise up 1, 2, we run over 3, so it's 2/3. So this is negative 3/2. What? Oh, it's parallel. I put perpendicular. I'm cool with it. I didn't read the question. All right, so let's do a parallel equation. Oh no, we're not gonna do, well, I guess we could. So which one's gonna be parallel? No, this one's all supposed to just be graphing. But if we want a parallel line to y equals 3/8 x, we don't care about the plus two. We just need one that's also gonna be 3/8. That's gonna be a negative. That's gonna be negative 3/8. That's it. And this one's gonna be 3/8. Okay, so this one matches too. So we're minusing the 3, and we're dividing by 8. Oh, it's gotta be negative. It's parallel, so it's gotta be a positive 3/8. That's positive 8/3. That's negative and negative, and two negatives make a positive. It's this one. I was just doing the formulas in my head. Cool. Which is perpendicular to y equals 0. So that's the x-axis. So it's got to be y equals a number. Oh, yeah, because it is horizontal. So the other one's up and down. Which is perpendicular to this. It's got to be a negative. That's negative 5/4. This is positive 4/5. This is negative 4/5. Cool. All right. Find the slope. All right, we did enough of these. I'm taking this one out. Okay, let's do parallel and perpendicular through a point. Which equation of the line that passes through this and is parallel to this? Okay, so this is a good problem. That'll teach you kind of everything. So x minus y equals 4. We want it in terms of y equals mx plus b. You got to minus the x to both sides. So I have a negative y equals negative x plus 4. Divide both sides by negative 1. So then I have regular y equals x minus 4. There's my slope 1/1. So it's parallel to that, but we just need the b. So right now we know it's y equals 1x plus b. We got to use this point. That's x, that's y. So we have negative 8 equals negative 2 plus b, because 1 times negative 2 is that. Add 2 to both sides. Negative 6 equals b. And there's your equation. Y equals x minus 6. And those are the steps. And there's the pretty picture. Cool. This is the exact same one, but now it's perpendicular. So this is y equals, so I'll start from the beginning. So negative x plus y equals negative 3. We got to add x to both sides. So we have y equals x minus 3. So what is perpendicular? This is 1/1. So we know it has to be y equals negative x plus b, and there's your point. So 2 equals negative 7. But it's 2, that's why you should always have parentheses, because 2 negatives make a positive. So 2 equals 7 plus b minus the 7s. So your final equation is y equals negative x minus 5. That should be a choice. Here it is. I don't know why they switched again, just to make it harder. Craziness. Crazy. Okay. Find the equation for a perpendicular bisector of the line segment. So we know this is 9, 5, and we know this is 5, negative 9. Without the graphs, these are crappy. So it has to make a right angle and cut it into 2 equal parts. So we have the point 9, 5. We have the point 5, negative 9. So we need the middle. We need the middle. So between 5 and 9, right? Find an equation of the perpendicular bisector of this line. Okay, so we need this, and then we need the slope. So the slope of this is we go up 14. We run over up 14 over 4. So it's 7/2 is the slope. So if ours is 7/2, it's going to be -2/7. So y equals -2/7. And then all we need is this point because this is the point that goes through it. So we need the midpoint. So the midpoint between 5 and 9 is 7. And the midpoint between -9 and 5, -9 plus 5 is -4. Half of that is -2. So it's going to be 7 -2. So -2 equals -2/7 times 7 plus b. These cancel. So we just add 2 to both sides. 0 equals b. Really? It hits at 0? That's wild. Y equals -2/7 x. That one was crazy. It was hard. It required a lot of thinking. The picture was off, but I still got it. All right, we did this one already, the congruence of corresponding parts. The two things are not congruent because non-rigid formations, IM matches to us. Cool. So QU matches to EF. Cool. Angle C, where you at? C matches to N. Cool. Okay, so we have HBE matches to TZC. B is 113. T, we can't figure it out. We can only figure out C, so we cannot determine this. These are similar. So it is congruent and it is similar because it can be matched. And so the scale factor is just 1 because they're exactly the same. Are they exactly the same? They look exactly the same. Ta-da! Ta-da! A translation, which one is first? C to D. So a translation to the right. We're going 1, 2, 3. I'm going 3. And we're going a translation down. 1, 2, 3, 4, 5. I'm going down 5. Does it match? Oh yeah. Two units to the right and 2 units up. 2 units to the right, 2 up. 2 units up, 2 to the right. 2 units up, 2 to the right. This was a translation. 2 right and 4. Oh, wait, which one's first? L. Okay, so K is first. So it's left 4 and 2 up. Nice. All right, so this one is a rotation. We're going let's go 90. Let's try 180 clockwise, followed by translation. I can't visualize it. So it's not that. So it's a reflection over the x-axis. So let's see what that happens. Nope, let's do it over the y. And then let's rotate it. I think this is it. Oh, I just went the wrong way. Oh man. All right, so let's do the rotation first. Rotation of 90 degrees, followed by a reflection over the x. Let's see what that gives us. Let's do this way and let's try it over the y. Will that give it to us? Oh, well, that's it, but it's a translation after this. To the right. 1, 2, 3, 4, 5, 6. Wild. Play around with this. It'll help your brain. Crazy, crazy tough. Crazy tough. Rotation of 90 degrees counter, followed by a translation. I think it's just going up too, but that's just my brain. Oh, it's the other way? Ah, if it was this figure, I would have had it. Well, you don't have to do it twice, so we're taking this out. And we're gonna do the discovery, but not this one. Well, let's see what it looks like first. So this is a reflection over the y over the x-axis, followed by a rotation. Let's go 90. Let's do a rotation of 180, followed by a translation to the right of 4 units. Cool. So I'll take the other one out. Without the discovery, it's just too hard to do. So this is everything. This is all of that one. I know it was long, sorry, but I really want to share a lot, and I hope all of this is clear. I hope you learned a ton of geometry. The last one's just measurement. It's really easy. It's short. So I'll make the quiz for this one and enjoy your day.